So this is my presentation on decarbonization in the US. You can see the US energy intensity of the economy on the left-hand side here. This is the energy consumption of the US in quads over the gross domestic product in millions. So you can see that going down somewhat over time. And then next to it is the US carbon intensity of the energy in the US. So it's the CO2 equivalent emissions in kilotons ratio to the energy consumption. So how carbon intensive is that energy consumption? You can see it's been going down, but kind of wobbly, not as straight as the other line here of the US energy intensity of the economy. And then I have my US rates of decarbonization. You can see the 1980 to 2011. And what I did here was I took that CO2 equivalent in kilotons and put it over GDP in millions. And it's going down here at a rate of about -5% from 1980 to 2011, and then I pulled out 2001 to 2011, and you can see it's a bit slower in its decline. It's more like -4% there from 2001 to 2011. And for the next calculations, I needed GDP further out than more of like a predicted GDP. So I took the trend line that matched most closely with the GDP since 1960 and then projected it out into the future. And I used that for the next graphs I'll show with 2020, 2030, and 2050. So the rate of decarbonization from 2012 to 2020 to get to 20% below 1990 emissions. So again, I took that CO2 equivalent in kilotons over GDP. So I did some estimations of GDP in 2020 and then also looked at our goals for emissions in 2020, the 20% below 1990. So I used this growth rate equation here and took the 2012 greenhouse gas over GDP rate ratio and the 2012 ratio, divided that 2020 ratio by the 2012 ratio and put it up to the power of 1 over the time, which was 8 years in between those, and came up with a -6.4 growth rate during that period. So you can see it here at the end, gets a little bit steeper than what it was before because the other ones were -4. And then looking at the goal of 26% below 2005 emissions, you can see the one that I just talked about is in the graph in blue, and then the 26% below 2005 emissions is in orange. So similar, I projected what the GDP would be in 2030 and took the goal of the 2005 emissions and 26% below those, and did GHG over GDP, and ended up, so ran that same equation, and for 2012 to 2030 would be a -4% growth rate. So similar with what we've already seen, and not taking that little turn that the 20% reduction by 1990, or 20% reduction from 1990 by 2020 takes. And then I also did the goal of 80% below 2005 emissions by 2050. So again, projected the GDP for 2050 and found the goal emissions taking 80% below 2005. Came up with the two ratios there and got a -6.5% growth rate. And you can see on the graph, it's the one in gray, and it actually overlaps with that blue one. That's why you can't see the blue one. And so that would get us to the a negative 6.5% growth rate starting in 2012 would get us to that 80% below 2005 emissions goal. And I looked at the nationally determined contributions that were submitted to the Paris Climate Agreement from the US. And what the US stated was a goal of 26 to 28% below 2005 levels by 2025, with a strong effort to get that 28%. So that's the one that I used for my calculations. And so you can see the CO2 equivalent emissions in kilotons here for the US. And it gets all the way to 2012, and then that's where I found the growth rate that would be needed, and that's where it starts that straight line going down. So the 2005 emissions were 7 million kilotons of CO2 equivalent, and that would make the 2025 goal about 5 million kilotons. That's that 28% reduction. So I ran that same calculation that I've already shown and got a negative 1.56 percent growth rate needed for the emissions of CO2 equivalent between 2012 and 2025 to reach this goal of 28% below 2005 levels. And the US didn't really state a 2050 goal in their submission of the nationally determined contributions, so I just went with kind of the broader goal of 80% below 2005 levels by 2025. So I used the 2025 emission goal and then looked at the 2050 emission goal, which is about 1.5 million kilotons CO2 equivalent. And you can see where it has that straight line that we already saw from 2012 to 2025, and then that drastic, or more so drastic looking drop from 2025 to 2050. And that would be at basically a negative 5% growth rate going from 2025 to 2050 to achieve this 80% below 2005 levels by 2050. And so how much will this cost? I found some estimates for how much it would cost in the US to significantly reduce greenhouse gas emissions. Some reports say that the US could reduce their CO2 emissions from electricity generation by 78% just with the current technology and no new fancy batteries, with a new national transmission network that allowed states to share energy. So when wind wasn't blowing in one, that wind energy could be transmitted, or same with solar energy too. And so by a quote here from one of the articles I read, by switching to mostly wind and solar power sources with a little help from natural gas, hydroelectric, and nuclear power when the weather doesn't cooperate, the United States could reduce carbon emissions by 33 to 78% from 1990 levels, depending on the exact cost of renewable energy and natural gas. So that's for both of those scenarios, the articles didn't really give a price, but the assumption is that it wouldn't be overly expensive, especially for that top one, because there wouldn't be a whole lot of new technology and innovation. It would just be that new transmission network. And then there's one where Obama had a goal of 80% renewable energy by 2035. And that was estimated by the Energy Information Association, EIA, to increase utility bills by 29%. Some other groups thought that that would be significantly higher, especially in places that currently rely almost entirely on coal. But that was kind of the cost would be a 29% increase to utility bills for consumers. And then there was another goal of 40% reduction in U.S. greenhouse gases, or gas emissions from the 2005 levels by 2035. And the Center for American Progress estimated that that would cost about $200 billion annually in private and public investments, but that average public investment would be $55 billion annually. So not overly huge, still expensive, but potentially doable. And then here's an infographic I included from the Solutions Project that gives some more details regarding what would look like for 100% renewable energy in the United States. And my last slide here is how much will this cost, but on a worldwide view. So I'll start here with the infographic. Does, I think, a really nice job of looking at how much it would cost to go for the whole world to go 100% solar, and then wind, wave energy, geothermal, hydroelectric, and then a combination of all those. And that ends up being 29.46 trillion pounds, which is 21% of the total global wealth. So that's some statistics there from the Inhabit website. And then I also found some other articles that talked about construction of a worldwide wind, water, and solar system would cost 100 trillion over 20 years. And that would be paid through investments that are then returned by selling back electricity to customers. And then the Global Commission on the Economy and Climate estimated that the cost for global infrastructure needed to reach renewable energy and climate goals by 2030 would be $89 trillion. And then just one more estimate here is the International Energy Agency estimates 10.5 trillion to reach the climate change goals by 2030. So pretty differing estimates there. And a lot of what I read, there's a lot of debate on how expensive it will be, but these are just some numbers that I did find. And then you can see the references I used here.